there's a similar formula for acceleration. So we'll be able to find acceleration of points, and we'll also be able to find acceleration, angular acceleration of links. So let me give you an overview of the most important formulas before we start using those. So we are doing 16.7, which is relative acceleration analysis. Okay, what you have to be able to do before you actually solve problems related to acceleration is you got to remind yourself that if you want to find the velocity of b, okay, you have to find the angular velocity before you can solve for angular acceleration, is vb is va plus omega cross r b with respect to a. So you would need that before you can solve for accelerations. So the formula for acceleration is acceleration of b is acceleration of a plus acceleration of b with respect to a. It turns out that we can actually write the acceleration of b with respect to a as alpha cross r b with respect to a plus omega cross omega cross r b with respect to a. So it turns out that you can simplify this formula a little bit. The last term, which has two cross products, can be written down as minus omega square r b with respect to a. So this is the formula from previous part, and this is the formula we'll use. The only thing I want you to remember is this is true only for planar motion. Okay, what it means is it's only true when the rigid body is rotating in a single plane. If the rotation is in 3 dimensions, then this formula is not valid. Fortunately, everything in this course is going to be planar, so we can safely use this formula. But if you're doing 3-dimensional analysis, do not use this. I'll just give you an intuition about that formula, but you should read the book about more details about this formula. What the formula is saying is acceleration of b is acceleration of a, acceleration of b is acceleration of a plus something else. So that acceleration of a, so when this rigid body moves, the motion of b is given by the sum of acceleration of a. That's the translation motion. And the other part, the second part, these two parts, is related to rotation of the rigid body. So if you think as the motion of this rigid body is composed of two things, one would be translation, and the other would be rotation. So that is acceleration of A, and this is acceleration of B with respect to A. Okay. So when you solve problems of this nature, when you have a formula, again, there are two ways to do it. I talked about this when we did vectors. One is you try to write acceleration of b as a vector ij, same for acceleration of a, and same for everything on the right side. So when you equate the left-hand side to the right-hand side, you have components in I, you have components in j. From those two equations, you can solve for typically two unknowns. The other way to do it is to write that equation as components, the magnitude and direction, and resolve components in the x and y direction, and then solve for the unknowns. So pictorial way, which is the second way, magnitude, directions, or as vectors. Okay, and so we'll solve some problems where it will be clear. I will not use the pictorial way because essentially boils down to using the same thing, except that you're just showing arrows, but it's absolutely fine if you do it that way. So here is the first problem. So find the acceleration of point P when the disk, in this case, is spinning with an angular speed of 4 radians per second and angular acceleration of 2 radians per second square. And both those things are clockwise. Okay? The key information is it's not slipping, which means that the point of contact has a velocity and acceleration of 0. That's the key thing, which we'll use. So when you see a problem of this sort, when a disk is not slipping, or even for that matter slipping, the key is to first find the velocity and acceleration of point A. And once you find the acceleration and velocity of point A, you can find the acceleration and velocity of point B. So you start off, let's call this point C. So no slipping implies acceleration of C is velocity of C is 0. Sorry, you cannot say this. You can only say the velocity is 0. Okay. Velocity of A is omega r times I. Okay. So that's true because if you think of one way to think about this system is it's as if it's pinned at C and A is moving. So when velocity of C is 0, velocity of A is going to be omega times r C with respect to A. And it's kind of a weird thing, but this point C is actually moving, right? The point of contact is moving as the disk moves. But this is another way of thinking about the same problem in terms of a link. So that's how I got, which is omega r. So this is how you get velocity of A. So the only reason we want to find velocity of A is because we can use that to find velocity of B. Velocity of A plus omega crossed with r B with respect to A. So velocity of A is 4 times the radius, which is 2 meters, times I plus omega So what's the angular speed? It's 4. And what's the direction? What should I put? Is it 4i, 4j, 4k, minus 4i, minus 4j, minus 4k? There are 6 options. Minus k, right? So why it's minus k? Well, first of all, when the if you want to find the direction of omega, you got to curl your fingers along omega, and your thumb gives the direction of the angular speed. So when the thumb points inside the plane, it's negative k. Crossed with, I need to find the vector from A to B. So from here to there. I'm going to make up a coordinate system here, x, y, and now I can find the vector A to B. So the vector A to B is going to be the length times the vector in this direction. So that vector is at angle of 45 degrees, so I need to resolve it along the x-axis. So it's going to be cosine 45, but the cosine 45 points in the negative x direction. So negative cosine 45 degrees I cosine 45 degrees I negative, and then if I resolve the same thing in the y direction, it's going to point upward, so plus sine 45j. Okay, so this gives me 8i, 4 times 2 is 8, cosine 45 is 0.707, I think. Okay, let me, okay, it's fine. So this k and this I, so minus 0.707 k cross I plus 0.707 for sine 45 k cross j. Okay, if I want to find the cross product ijk, so that's to go from ijk in the counterclockwise direction.
How is that not negative 4K?
How is it negative 4k?
No, how is it not negative 4K?
Did I do a mistake somewhere?
I'm just wondering how it's not K anymore.
You mean here?
Yeah.
I moved that inside.
Oh, okay.
Yeah, I just plugged the 8 out. I took this 4, multiplied with this 2.
Okay.
So k cross I. So if I go from k to I, I'm going in the counterclockwise direction. That should be j. And then to go from k to j, I go in the clockwise direction. So that's going to be negative I. So eventually this comes out to be velocity of b. So after doing all the math and simplifying, it's 2.34 I plus 5.65 j. Okay, so well, you do not need anything in 16.7 to solve this. This is just the velocity analysis. You only need what we learned two lectures back using the relative velocity formula. Okay, now is the part when we try to solve for acceleration. So acceleration of A, which is this point here in the middle, is also going to be in the same direction. It's going to be, so if the disk spins with an acceleration of alpha in the clockwise direction, and the acceleration of point A is going to be to the right, and it's going to have a magnitude of alpha times r. So another way to think of this is, why isn't there a j component? Why is there only an I component? If there was a j component to the acceleration at A, then the disk would fly in the air because of the acceleration in the upward direction. But it doesn't fly in the air, it's still stuck to the ground. So the acceleration in the j direction is 0. So that's the acceleration of A. So now we can use the relative acceleration formula. alpha b is alpha a plus alpha cross rb with respect to a minus omega square rb with respect to a. So alpha a is AA is alpha RI plus. What about alpha? Alpha is 2. And what's the direction of alpha? Is it plus k or minus k? Minus k, because alpha is in the clockwise direction. So minus k crossed with the vector from A to B, which I wrote down here. So that's going to be 2 times minus cosine 45 degrees I plus sine 45 degrees J minus omega square, so it's 4 square times the same vector. So I'm going to write this down here. 2 times minus cosine 45 degrees I plus sine 45 degrees J. Okay, that's a little bit of more math than the previous step, but now what you need to do is, for this one there's no problem, you just carry over I and J, but here you would have to do K cross I and K cross J, using exactly the same technique I told you earlier. You'd have K cross I, K cross J. Okay, so you can complete this. I'm going to just give you the final answer. So show that AB is 17.3 I minus 8.49 J. Okay, any questions? So you should fill in the details. Okay. Any questions on this? So this was a straightforward problem where I gave you angular velocity and angular acceleration. Most times that will not be the case. You can expect a problem like this in the exam. A mechanism where you'll be given some things and a bunch of things will not be given. So in this case, remember AB has angular motion shown. So you're only given the angular velocity and angular acceleration of AB. Determine the velocity and acceleration of the slided block C. Okay, so given accelerations and velocities of one link, you're told to find the accelerations and velocities of some different point. And so you'll see in this question, it will be recursive use of the formula. Either VB is VA plus second part, or AB equals. You do it for different points to get that. So let's solve this. So VC is unknown, VB is unknown. Sorry, AC is unknown, or it's asked. Okay, so in all such problems, what you see is, if you know something about this link, like you know the acceleration and velocities, you can find the acceleration and velocity of point P because you know everything about this link. So once you find the velocity and acceleration of point P, you can then find a relation between velocity and acceleration of C and B and use that formula to find the unknowns, which will be BC and AC. Okay, so we'll proceed that way. We'll first find velocity and acceleration of B, and then we'll try to relate that with C and solve for what is asked. So velocity of B is velocity of A plus angular speed of AB crossed with RB with respect to A. So velocity of A is, what's velocity of A? It's 0 because it doesn't move. Angular velocity of AB is 4, and what's the direction? It's positive, so positive k. What about the vector from A to B? So the length is 2, and what's the direction of the vector from A to B? Right. Okay, you cannot answer this question because I've not put the axis, so I need to put an axis there. So if there's no axis in the exam, you should put an axis because that question has got no sense if I don't show you the axis. So now what's the vector from A to B? It's 2j. So it's 8 I j k. So when you go from k to j, you're going this way, that's going to be negative I. So velocity of B is negative 8I. Does that make sense? Well, if link AB is going this way, turning this way, then B is clearly going to move in the left side, which is negative I. So that makes sense. Minus 8I makes sense. So let's find the acceleration of B, which is acceleration of A plus alpha AB cross RB with respect to A minus omega square RB with respect to A. So A is fixed, so acceleration is 0. Alpha AB is shown to be 5. What's the direction? Negative k, because 5 is in the clockwise direction. The vector from A to B is 2j minus omega is 4 square times the vector from A to B is 2j. So again we have k cross j, like previous case, so minus I minus 4 square, 8 times 2, 16 times 2, 32. So acceleration of B is 10I minus 32j. Okay, so now let's try to move from, so we found everything about B. Let's move to C. So velocity of C is velocity of B plus omega BC crossed with R C with respect to B. Okay, so we know velocity of B. We do not know the angular velocity of BC. So we can make a guess. Let's assume that angular velocity of BC is counterclockwise, and if that's wrong, then the sign will come out to be negative. Do we know the vector from B to C? Let's see, we're given this is 2, this is 0.5. I think we can find the magnitude for sure because this is 90 degrees, so we can find the magnitude. What about the direction of BC? Let's try to write this. Right, that's the magnitude. What about the direction? How will you find the direction? Yeah, so by the way, what's this? This will help us. What's 2 square plus 0.5 square? That's 2.06. Okay, so what we know is about BC is that this is 2, this is 0.5, and this is 2.06. So if you want to find the vector from C to B to C, this vector, then it's going to be, well, we are only interested in the unit vector. We already found the magnitude, so that's going to be BC, so it's going to be 2 divided by 2.06. That's going to be the no, sorry. So we want a unit vector in this direction. In the I direction, that's going to be 0.5 divided by 2.06, right? So how do you get we need to find the I component, we need the cosine of theta. Cosine of theta is going to be 0.5 divided by the hypotenuse, 2.06. And this vector is going to be in the negative direction. Similarly, you want to find 2 points. So this unit vector or unit length times sine of theta. So sine theta is going to be 2 divided by 2.06. And since it's pointing downwards, that's going to be negative. Right. Okay, so that is one way to do it. That will actually set you up how to do this particular part. I did exactly like that. The other way to see that is actually, you don't have to do all this math, what I showed here. You can simply notice that if this is the origin, 0, 0, then this point is going to be 0.5, 0, and this point is going to be 2, 0. And given those 2 points, now you can find the vector, right? How do you find the vector? It's position of C minus position of B. So it will be 0 minus, so the Y component will be 0 minus, it should be 0, 2. 0, 2. So in order to find this, it's going to be 0 minus 2, so that's the 2 over here, and minus 0.5 minus 0, so that's going to be the other one. There are 2 ways to do it, whichever you prefer. Okay, so coming back to this, we know what B with respect to C with respect to B is. We do not know angular velocity of BC, nor do we know velocity of C. That's an unknown. Okay, we know that omega BC can be in the K of positive K or negative K. So there's one unknown in there. Velocity of C, however, we do not know velocity of C, the magnitude. What about the direction? Do we know the direction of velocity of C? We know that the slider is sliding along this slot. Do we know the direction of the slot is? We do know it, right? We're given 3, 5, 4. So given that, we can find the direction of velocity of C. So velocity of C is going to be velocity of C times, so if you like, this is 3, 5, 4. Let's call this alpha. It's going to be confusing with the other alpha, so it's called beta. So velocity of C times the unit vector in the direction of C. So this direction. So that's going to be sine of, sorry, this is going to be cosine of beta, pointing in the negative I direction, like so. And then the other component is going to be sine of beta, pointing in the negative J direction, like this. But cosine of beta is 4 divided by 5. That's true because it's the adjacent side divided by the hypotenuse, and sine beta is going to be 3, which is the opposite side divided by the hypotenuse. And omega BC is omega times BC magnitude times K. So we can set this up now as VC minus 0.8I minus 0.6J plus omega BC omega BCK crossed with the vector from B to C is going to be, so this 2.05 by the way cancels with this 2.06 cancels with this and this, so we'll be left with minus 0.5I minus 2J I'm forgetting velocity of B, so velocity of B is minus 8I, so this should be equals minus 8I plus this part. Okay, so minus 0.8 VCI minus 0.6 VCJ equals minus 8I plus omega BC times 0.5. K cross I is going to be J, so minus J, and then 2 omega BC. Then I multiply this with this. I'll have K times J. So K times J is I. Well, K times J is going to be, when I go from K to J, it's going to be negative I, right? K to J. So negative I. Plus 2 omega BCI minus 0.5 omega BCJ. We can compare both sides. Equals minus 8 plus 2 omega BC. Okay, so comparing the I components and then comparing the J components, we get minus 0.46 VC is equals minus 0.5 omega BC. So solving these two equations, omega BC is 3 radians per second, VC equals minus 2.5 meters per second. Okay, similarly, acceleration of C is acceleration of B plus alpha BC crossed RB with respect to C minus omega square RB with respect to C. Okay, I'm going to run out of time if I don't go to the next problem. I'm going to post this later on, but let me just briefly tell you how I'm going to go about solving this. I know alpha acceleration of B. I do not know alpha BC. I can assume that to be alpha BC times K. Okay, I know the vector from C to B. I just found that out. I did this. I found this out. This came from omega BC. I just solved for omega BC. I solved for this right here. So I know that. Okay, so this is an unknown. I can write this as AC times the direction, which is going to be minus 0.8I minus 0.6J. Right? So I'll have two unknowns, AC and alpha BC. And just like the previous problem where there were two unknowns, VC and omega VC, I can solve for those two unknowns. So I'll complete it later on, but that's how I would do this. Any questions on this? So it's a lot of math, but you're going to go very systematically, very slowly. If you do not get this right, it's going to affect what you're going to get when you solve this because it relies on omega BC, which came from the first part.